Yo, what's up? What's up, Zai myself? Good to see you from earlier today when I was running the machine. How are you doing? How'd the run go? What's up, Mayu on Twitch? The run actually, well, the run didn't go so well in terms of like making it work. The run was okay. We didn't get many vapors for some reason that came out, which means we didn't really get any fuel. But in terms of like actually testing the machine, the run worked good because we were able to successfully test the blades while the magnetrons were on to make sure that we could run the blades without the machine exploding like it has before when doing that. So we didn't have any issues. Oh, I unplugged my camera. Oops. What's up, everybody in Discord? Getting these other things started here. You said I can't be here for a while since I have to go to sleep very soon. Oh, no worries, man. You were there for pretty much the whole live stream when we were running the machine. Guys, I usually run the machine in the daytime. Earlier in the days, we run it live. Today, we were live for almost 3 hours. Trying to go live on TikTok here. Here we go. Boom. Feel like with such a long reactor, the penetration is going to be a bit difficult. Well, here's the thing, Mayu. It's kind of tough to know right now because we only have 2 magnetrons, 2 of 12. So, it may be an issue, but it may not be an issue once we're at full power, right? So it's kind of like these test runs are primarily just to make sure everything is optimized as we build the power up more and more. So that way, like if we have leaks, we can see them way ahead of time, right? Or if we have potential weak points, we can see them way ahead of time before doing it with such high power, because anything with such high power is more exponential, right? So you don't want to have even a small leak with 12 magnetrons going on at once, right? That could become completely disastrous. So that's kind of the whole point of all these test runs we do for that reason there. Just for so to slowly build up to that point. And it's the same thing I would do anyways. Like with Mark IV, I didn't turn on 3 magnetrons until the first few runs in Mark IV. Once again, for the same reason, the same safety reasons of just, I'm not about to go over here and turn all these things on at once just to find out we had a weak point and that thing completely explodes. Especially now since I'm running the machine under vacuum. Since I'm running it under vacuum, that's a whole nother set of things that could go wrong too. It could suck in oxygen, and then now it is literally a pipe bomb, right? So, what's up, guys, on Instagram? If you want to come in and ask your questions, you can come in. I'll be letting you in. You guys on Discord, if you raise your hand, I'll let you in to answer your questions on Discord. Thank you, Beatriz. How are you doing? Or Beatriz. What's up, everybody on TikTok? You guys can request to come in as well, and then I'll let you guys in. So we just came off of a 3-hour live stream earlier today, running the reactor. We're still in the test run phase, doing a little test with it, making sure it's nice and safe as we're starting to build up. But the goal is, what is it? It's Friday. I want to have 3 magnetrons on latest Monday. The thing is, to mount every magnetron, right, or to increase the amount of microwaves on the machine, it takes some time. Hey, much love to SoCal. It takes over a day to make a single one, right? And here's the issue. If I'm running the machine, I'm not building one, right? So it's like I have to kind of pick. Do I want to run the machine, or do I want to build the magnetron mount? So that way when I run the machine, there will be more power, right? Sometimes I want to run the machine more than anything, but it's getting to a point now where it's like I want more power on the machine. But at the same time, we spin the blades of the machine, and that's a whole different variable. That's a potential place for leaking. It's a potential place for pressure spikes and small explosions. What I'm going to do is tomorrow I'm going to get out there real early. So maybe I can do a little bit of both, Start the day, start building one, probably build like half of it, and then build the other half on Sunday of the magnetron mount. So that way we can have, you know, 3 magnetrons on there. I want everybody to remember my Mark IV reactor had 3 magnetrons on it. So right now, with just 2, we're not even at the operational power of what Mark IV was. For anybody that remembers Mark IV, which was over a year ago, how do you calculate how much ethanol is in the gas? Ethanol is an additive to gasoline, so there's no ethanol in gasoline at all when it's actually made from refineries. It's added after the fact. Please share this truth on social media and Rumble, please. Yeah, LJ Corey, I gotta get on Rumble. So I already have a Rumble account, but what I gotta do is I gotta get my Rumble uploads back up on, you know, get back in the game. What's up, John Kelly on Facebook? Yeah, I can't let you in, Stan. I see that you want to request to join in on Instagram, Stan, but it's not letting me let you in. So, you gotta, I don't know, I'm not sure what's going on with that, actually. It says you're unable to join. Yeah. Oh, we got a question on the Instagram. Why are you so fine? Okay, well, that's clearly off topic. Let's talk about why is plastic so fine? Why is plastic so fine to utilize to turn it into fuel, right? Because is that a coincidence that something that's so polluting, right? Something that's so destructive to our environment is also the perfect candidate to make fuel? It's actually no coincidence at all, right? I'll tell you why. The reason why plastic is non-biodegradable is actually the same reason why it makes amazing fuels. It's the exact same reason why. And I'll tell you. So, what makes plastic non-biodegradable to begin with? Well, on a molecular level, plastic is made of what we call hydrocarbon chains. So hydrocarbon chains, well, everything that exists is made of bonds and chains on an atomic level, right? A molecular level, right? And plastic is made of those as well, but plastic's hydrocarbon chains are very long, right? What does that mean? Well, that essentially means, like, well, I have a visual example here. I don't have anything I can grab. Well, I have a little paper clip. Okay, how about this? Yeah, perfect. Okay. I have a paper clip over here. We'll do a paper clip. So let's say a piece of wood, right? A piece of wood on a molecular level is like this paper clip here, right? You see? It's that length. Now this paper clip, if let's say bacteria or fungi want to come eat this wood, their mouth can fit around this, right? Plastic is like this. It's double the length of this, as you see. So if that same bacteria wants to come and eat the plastic, it can't. Its mouth can't fit around it. It's not big enough, right? It's kind of like your mouth when I want to put my balls in your mouth. It's just not big enough for some reason. So since the plastic chains are too long for bacteria, it doesn't biodegrade. Because there's bacteria and fungi that biodegrade things, right? So it doesn't biodegrade. And instead, the only way to break this apart is with heat. And we utilize the process of pyrolysis. And the process of pyrolysis is when you take a material and you put it in the absence of oxygen. Why is everybody laughing? You guys need to focus, okay? You take a material, you put it in the absence of oxygen, and then you heat it up. And since it's in the absence of oxygen, it cannot catch on fire. And since it cannot catch on fire, see, if it caught on fire, right? That plastic is just going to turn to smoke. So yeah, these bonds are going to break, but it's going to be burnt right away. It's going to turn to smoke, bad emissions, nonsense. However, since there's no oxygen, it cannot catch on fire. This bond actually splits into smaller bonds. So this ends up turning into this. Now it's half the size, right? But now it's a vapor. Plastic turns into vapor. The bonds break and shorten, and those bonds end up going into our condensation system, our gas collection system. And now these bonds, since they're broken apart, they're the fuels of this world, right? Because you can take something out that was in there, for example, right? So when the plastic's bonds are this long, they're called hydrocarbon bonds, going back to what I was saying before. Hydrocarbon bonds, hydrocarbon, hydrogen and carbon. hydrogen is the most energy dense molecule in the universe that we know of. So if I'm telling you we have a hydrocarbon bond full of hydrogen and carbon, that means the longer the bond is, the more hydrogen, which means the more energy. Now, plastic's hydrocarbon bonds are like this long, okay? They're like this long. You know how long gasolines are compared to plastic? They're like this long. You know how long diesel's hydrocarbon bonds are compared to plastic? They're like this long. The only thing that can finally kind of, get close to plastic is motor oil, which is like this long. But still, plastic is longer. Plastic has more energy in it than gasoline, diesel, jet fuel, motor oil. The most energy dense things. So since it has so much energy in it, we're not creating energy. We're not creating it. We're just taking it from there. It already has the energy in there. We're just taking it from it. And we are transforming that energy into a different form. Transforming the energy that already exists in the plastic, a very energy-dense substance, and just transforming it into crude oil, what the thing came from, reverse engineering, right? So, that's the process in a nutshell, when you're breaking it down in layman's terms there, with some paper clips and some nuts in your face, right? We got somebody on Discord that wants to come up. What's up, Hassan Ford, 1984? You're up on Discord. Are you here? Because I'm requesting you to come up on the Discord. All right, I don't think he's here. Let's see. Memory asked on Instagram, do you think balls have microplastics in them? Well, what type of balls are we talking about? Whose type of balls are we talking about? You're probably asking, do mine, right? Well, do my balls have microplastics in them? Do I think my balls have... No, so here's the thing about my balls, right? I don't think it's possible for my balls to have microplastics. My balls have macroplastics. What's up?
Hey, greetings from Tennessee. It's been a long time. I'll continue to follow your adventure. I love the new Mark IV design. It's a continuous speed, you say.
Yes.
It's got like valves. Is that how it does the continuous speed?
Yeah, we have a double valve system.
Okay. So that's really cool. That's really excellent. And I imagine it could be scaled up to like even bigger sizes where it could take like a whole garbage truck or a freaking 8-yard dumpster worth of plastic at a time.
Yeah, that's the point, of this design, is that this design is, is scalable, right? This, I'm building it at a small scale in my backyard, but the idea is that this exact same design with just bigger parts and things will work on a bigger level.
Now, Jab, if you can build a reactor like this, do you think you could build like a cyclotron or a particle accelerator?
Well, those things are not particularly in my interest. However, there are patterns.
There can be tools that produce microwaves, so you could get like a bigger magnetron out of it.
That's true.
Bigger, more powerful magnetron, or something like a gyrotron.
Yeah, and when you think about it, right? Even like a magnetron. So, like, when I'm building these reactors, it's very mechanical. I'm building these blades. When I'm starting to get into, like cyclotrons, magnetrons, those things start to become very sophisticated on the electronic spectrum. I'm actually not very well versed in electronics. I wire together my reactor based on basic schematics and basic wiring knowledge, but when it comes to electronics, I'm really mostly a mechanical person, right? But there's so many different forms of energy and electricity that are being developed every day. Yeah, there's so many different forms of electricity being developed like every year that I truly believe that when it comes to this machine powering, it won't even be an issue long term at all.
Another thing I was thinking of, in this reactor, the other ways to decompose the plastic, what I'm saying is the magnetron, you might be able to get a bigger like oomph out of a particle accelerator based magnetron.
Yeah.
There was also there's a lot of different web pages, and I'll link you to some of them that have like designs and blueprints for how you can build things like cyclotrons and betatrons and other particle accelerators in your garage. A lot of people have. So I can give you that information.
Okay. Okay. Well, yeah. Thank you. I got some other people I gotta let in, but I'll be looking forward to that information. I didn't even know you could do that at home, but that's true. And you know what? That reminds me, because a lot of people, right, think that because we live in an age of, scientific labs and things, that there's really no place for the garage experiments anymore. But I truly believe that there's always a place for experimenting in the garage. And when you think about it, almost all the best inventions and most useful things ever have come from garages, not from these sophisticated $1 million budget labs. Because sometimes the truth of the matter is limited resources makes you the most innovative, right? To me, it's basically an attachment for a gasification chamber. The same thing is done with oil, where they boil the oil and capture the vapor to make petrol. It's similar to gasification, but it's not. In fact, the first step of gasification is pyrolysis, but the difference is gasification does not make any oils, right? When we turn plastic into fuel, we're making not only gaseous vapor fuels like natural gas, we're making actual oils too. I wanted to ask, how do you differentiate octane levels? So I haven't differentiated them because I don't have the tools to test octane. The thing about octane is that octane is almost always an additive, right? So when you have your gasoline from the pump, 83, 87, 93, in order to get that octane up, they just add an octane booster to it. And that could be any variety of things. It could be ethanol. It used to be lead, right? So I'm not concerned about octane at all, because as long as my octane isn't too high, right coming out of my plastic, right, I can always make it higher. You can use a magnetic energy to power your machine. You can use anything that makes electricity. So if there does exist an efficient and optimal magnetic generator, yeah, it can power the machine just fine. Let's say theoretically the plastic's molecular bonds weren't shrinkable in some level. Would that affect your complete project? The plastic's molecular bonds were not shrinkable. So you're saying if the hydrocarbon bonds of plastic were not possible to break apart, well, if the hydrocarbon bonds of plastic could not be broken apart by even heat, then no, it would not be possible to revert plastic back into fuel. But fortunately, plastic follows the laws of every other thing in the universe, and anything that comes together can be destroyed. So we can turn plastic back into fuel. You said, I'm a badass welder, let me donate my services. Oh, well, I appreciate you for wanting to help out on that. When I'm building Mark V, the first industrial machine, then I think that would be like the perfect time, because I have to bring welders on board anyway. So yeah, send me an email, business@naturejab.com. Let's see. Yeah, I saw that you had answered asked your question, Stan, in that little question thing. However, Stan, I'm trying to let you in. It's still not letting you in. So if you have another question, you can ask it there. Thank you for the donation, goddamn sorcerer. And I remember you, goddamn sorcerer. I've seen you on Twitch as well. Thank you, Kara Warhol, for the roses on the TikTok. I appreciate you guys. Have you tried your fuel out? Yes. So I tried my fuel in weed whackers, in diesel engine, a Power Stroke engine, 1995, a go-kart engine, diesel go-kart engine. Oh, what else? It was a 2-stroke and 4-stroke weed whacker. We do make gasoline, diesel, and jet fuel. So not just one or the other. We make all three. All right, I'll let you in, Leo. Like I said, Stan, it's not letting me let you in. Can you make it scale to mass production? Yes.
Hello?
What's up?
I was just wondering, isn't your design just a big fractional distillation column?
Yeah, pretty much.
Well, so you just melt the plastic and then put it in the chamber and then it would evaporate?
Well, I don't. Yeah. So in the chamber, the plastic melts and then evaporates. I don't melt it beforehand.
Oh, right. Cheers.
Oh, yeah, that's it. Cheers. Yeah, so this is actually considered destructive distillation. it's not necessarily fractional distillation because I'm not fractionating the products. Like when I'm getting my oils, they're all coming into one thing, right? All of my oils are mixed together. I'm not fractionating them out. Instead, my focus is not fractionating oils, like getting, oh, I'm just getting gasoline, just getting diesel, just getting jet fuel. They all mix together. My focus is on destroying the plastic altogether, right? Regardless of what that means. Because when you do actual fractional distillation, when you're trying to get specific oils out, specific liquids out, you control the temperature up and down. But I'm merely trying to destroy the plastic. So I go up to the temperature of destroying the plastic and I'll never bring it down, right? Trying to get certain things off. I'm there to completely destroy it. So I'm a little bit different from a fractional distillation. It's considered destructive distillation. However, it is the same principle. Just it's distillation, right? It's going in the chamber, evaporating, and then we're condensing it. So it's the same principle. We got a question. Oh, this is the same question I just answered. Have you considered standardizing the type of plastic for your reactor, i.e. the X number of hydrocarbon chains? Well, here's the thing, right? Every plastic is different. Styrofoam is different than a plastic bag, right? So, since that is the case, on a molecular level, certain plastics will give you more fuels, different types of fuels than others, right? So, with that being said, there is benefit to having some organization and knowing, okay, I'm just putting in plastic bags, I'm just putting in water bottle caps, I'm just putting in styrofoam, because you will get better fuel yields with each different one. You know, for example, I'll say like styrofoam gives less oil. One of the best oil yielding plastics is polypropylene, which are like water bottle caps, right? But at the end of the day, right, it doesn't really matter in terms of. So I'll say it like this. The reason I even built my reactor to begin with, the reason I even started this journey was to get rid of plastic waste. It just happens that we make fuel, right? The goal is to get rid of plastic waste. That's the end all be all, above all else, right? So when it comes to getting the perfect fuel yields, the perfect numbers, all these things, yeah, you want to organize stuff. But when it comes to just the goal, getting rid of plastic waste, blend it all together, mix it up, spread it all together, put it in the reactor. The reactor's going to eat it all up the same. And that's the goal. That's the point, right? It just happens to be that we're getting rid of plastic and we're also getting fuel out at the same time. But personally, I think it's just cool just to get rid of plastic, right? Because, you know, we haven't had a way of getting rid of plastic that's been so controlled and so safe, right? We have not had a way. Incinerators do not do it good enough because incinerators have a ton of fly ash. That's the ash after the things are burned. We don't know how to dispose of it, right? But pyrolysis turns the plastic into very valuable products, and it's very controlled. You guys see when I run my reactor every day, I mean, like, there's no, unless I intentionally open something up, the vapors are not escaping. They're going right from the reactor into our bladder to catch the vapors. We're not losing anything. And then the oils, obviously, we collect those and use those, right? And the carbon, collect that and use that. We don't, unless, like I said, unless there's an explosion or something intentional for safety or something that I'm doing, or I'm just trying to mess about. We really don't have leaks. We don't have things escaping, and that's just what we do. Have you done any optimization testing on the magnetrons? What size will have the least wasted energy? I've never done that type of testing, but I will have to, especially as these reactors get bigger and more serious. We want to have the optimum efficiency, and we don't want the magnetrons to be destroying each other's waves. We want every wave to be together. So I saw you update your machine, but what else? You added a few wires and what? So the biggest upgrade I recently done was making my machine possible for me to turn it on and off wirelessly. So I don't have to flip a physical switch. I can stand up to like 100 feet back and click a button like a key fob and turn it on or off. And that's amazing because, it's dangerous. I don't like being close to those high voltages when I turn it on. I'm still scared when I turn it on with the key fob from a distance. The thing might explode, but at least if it explodes, I'm a little bit of ways back, right? I'm not I'm not right up on it. So that was a huge addition. If you guys looked at my YouTube channel, you'll see that when I have a Mark IV reactor, I'd be so scared of that thing, I'd be turning that thing on with a stick, because I didn't have this wireless stuff. I would take a stick and flip the switches. I don't like being near it when it turns on. And when the transformers turn on, they're making that low humming buzz noise. It sounds like you're about to die. So I just don't like it, right? So having that wireless thing is really more of a comfortability, but, you know, that was definitely a huge thing for me. You said you turned it on your latest video? Yeah, I turn it on. I turn it on literally every day. Would the exhaust from a vehicle powered by plastic gasoline have a different effect than other gasoline burned today? So the exhaust really, it depends on how the plastic gasoline is processed, right? Because when we make gasoline from crude oil refineries, it's not just gasoline, right? Just pure gasoline comes right out. We have to refine it and purify it and run it through certain catalytic processes, right? So it depends on how it's processed. In the sense of my gasoline that I make, right? I don't have all the different cat crackers and things to make it super refined. But if we just run it through the same processes that already exists, in absolute theory, the exhaust would pretty much be identical, because there's almost nothing in plastic that isn't in crude oil anyway, right? In fact, plastic has less in it than crude oil has. For example, sulfur is removed from plastic, and that's something that is in crude oil. So if I make diesel from plastic waste, it's going to be no sulfur diesel. It'll be no sulfur emissions, right? Versus low sulfur emissions from actual diesel, right? Thank you for the $10, Grayling Gaines, on the Cash App. Grayling Gaines, you donate every live stream. I appreciate you so much. How much do you produce, and how long does it take to produce a batch, and how much weight can you do per hour? All of those figures, Sean, we're still coming up with as we're building Mark 4.5. I can only give you those figures for Mark 4. Mark 4.5 is its own animal, its own beast. So we're going to have to see what those numbers look like on Mark 4. That's kind of the whole goal. That's why we're doing the test runs. We're very we're very diligent with these types of calculations. You said my thoughts on the solar eclipse. Well, truth of the matter is, I think that people wait for something to come up, right? To finally start to be like, oh, maybe I should learn how to live without technology. Maybe I should learn how to start a fire. Maybe I should learn to do this. Maybe I personally think it should just be a lifestyle anyway. We shouldn't be as reliant on technology as we are. Do I think people like to overplay a lot of things. Like, we'll see what happens. I don't personally think it's going to be anything like a grit down situation. Maybe it will, maybe it won't. But I personally believe we should be focusing on that anyway, right? That should be taught anyway. We should be in that mindset regardless of self-sufficiency in homesteading anyways. We shouldn't have to have a solar eclipse about to happen for us to finally be like, oh, maybe we should actually be a little bit self-sufficient. No, we should be self-sufficient 24/7 all days of the year anyways, right? Just for the sake of, you don't want anybody in control of your life. You want to have control over your life. And you don't want to go to anybody, the government or the man or anybody, for your survival's sake. You provide what you need for survival, right? And that should be whether there's a solar flare happening or not, or a solar eclipse happening or not, right? Let's see. We got some more questions here. Where does the fuel come from? Is plastic made with fuel? Yes, plastic is made of fuel, color every day. So that's how we're taking it out. Plastic is essentially the solid form of fuel. We're just turning it back into a liquid. Do you plan on sending your creation to trash and recycling companies? Yeah, I want them to be a customer for sure. Definitely want, these waste management companies. I believe they'll be a big customer. I bet you there's a particular megahertz or gigahertz that just tears stuff apart with very little energy. That's so true, Sean. Because let me tell you, Sean, that's a very smart remark there, because there's infinite, pretty much to us as humans, infinite frequencies, right? We can never find them all. And what about, because the microwave's 2.45 gigahertz is tuned for water, most efficient for water heating. It's not tuned for plastic heating. So imagine if we find a frequency specifically tuned for plastic heating, we could instantly boost the plastic's efficiency just by that. Are you ever worried about the government? No. What if you insist instead of microwaves use sound? Microwaves are essentially sound. They're just at a different frequency, right? All waves are essentially sound. Certain frequencies you can't hear, you can't see. That's the thing about this universe. Everything is a frequency of some sort, right? It's like Nikola Tesla said. Hello?
You already answered my questions.
Oh yeah, I saw your questions in there. Well, thank you. I appreciate your support.
Thank you. You're welcome.
All right. Do you use multiple stock transformers to power the magnetrons? Yes, Josh. I take my transformers, capacitors, and magnetrons right out of microwave ovens. So the ones I'm using are literally the same ones you're using when you cook your Hot Pocket. Can it handle PET? Yes, it can. I've actually done a run with PET, purely PET on my YouTube channel on my Mark IV machine. But of course, Mark 4.5 is her own beast, so we got different tests to do with this. So I can't wait. What's up, Electronic Scrapper? It's always a pleasure to see you live. Well, thank you. I'm happy to have you in here as well. Oh, what's up, Sean? You said you remind me of a Black Nikola Tesla. Well, thank you. How old are you? I'm 20. So yeah, I miss any questions here? Yeah, we got all of them. Got it. Cool. Have you tested your equipment when it's running with a gamma meter? Oh, for microwaves? Yeah, I used to have a meter. It got burned in my electrical fire. I need to get another one. It's a safety thing, right? It's a good way to also know when microwaves are on without having to touch anything, because you don't want to touch these high voltages by accident. What is the benefit of the horizontal position versus vertically? Okay, that's a great question. So if you look at my machine, it's horizontal. It's like a hot dog. It's not vertical. It's not standing up and down. Why is that? My first ever microwave pyrolysis reactor was standing right up and down, right? And I've done that before. It doesn't work on a scalability level. I can build a machine that works standing up, but you can only load in so much plastic. You can't make it continuous with the microwaves. So the whole design of Mark 4.5, you can go on my YouTube channel. I had a video named Help Me Design My Next Plastic to Fuel Reactor. We talk about all this stuff, all the design decisions, but I'm telling you guys, every single design, from the reason why it's horizontal to the reason why the auger, the blades in there have no shaft, every single thing is extremely intentional, and very much thinking about all the little material sciences and interdisciplinary systems that we're putting together in this machine, the chemical engineering, the radio engineering, and of course the mechanical engineering. It's all a part of the design, and all serves a very important purpose, right? If you make the machine vertical, there's a lot of hiccups you're going to run into when it comes to scaling it on a bigger level. And the reason why we're even doing this to the point that we're doing it is because we're not just trying to make a hobby project in my backyard. I'm really trying to tackle with plastic waste. So we have to think long term, and we have to make it a design that's scalable. That's period. We have to make it continuous. So that's why, like I said, you look at Mark 4, look at Mark 4.5, they're almost identical. Mark 4.5 is just bigger. That's it, right? How would you describe your current impact on the world regarding your invitations? Mainly, how can we help spread your ideas with the rest of the world? I would say that, here's the funny thing, right? People, you might think that I would have my biggest impact on the world if I actually had this thing out there, getting the plastic out the oceans on boats and stuff. But I don't think that's the case. I think the biggest impact on the world is actually these moments now, the build up to that point, because these are the very humanizing moments that reminds people that they can do things too, right? 20, if I'm doing this at 20, you could do it at whatever age you're at. You could do it younger, right? You could do your own thing that you want to do, whatever it is, right? So I believe that it's those things. The inspiration is the true impact, because I can only do so much. But if you can inspire one person that inspires another person that inspires more people, eventually you inspire the whole world, right? Indirectly. And that's the true impact on the world. You said, what's the benefit? I'm curious how you figured out how to use thinner steel without bracing in your corkscrew. So, how does my auger work? My blades on my reactor, the spinning bits. Because a lot of people are like, you need to put a brace in them, you need to put a shaft through it, you need to do this, or it's going to fall over, it's going to break, it's going to jam up, it's going to clog. And people say what they say, but I was just back there like, hey, I can say what you say, but I already did this before on Mark IV, so I know it works. And the reason why is in the design of a shaftless auger. A shaftless auger is specifically designed where the whole body of the machine bears the weight of the auger. When you use regular augers, it's the shaft that bears the weight. The shaft is held up by the bearings on both sides. We don't want two-sided bearings, because two-sided bearings means that there's two areas you have to seal with a rotary shaft. You can't open the lid very easily. It's a nonsense. I would rather have one-sided, but you can't have a one-sided shafted auger. It's too heavy. The shaft is too heavy. It's not gonna work. You have like half of the auger like angled off of the base, and then half of it on the base. It wouldn't work. Shaftless auger, the whole point is every single blade is in contact with the metal. All the weight is being put on the belly of the metal. That's the whole point. So since all the weight is being put on the belly of the metal, that's where all the strain is and the stress is. It's not in the actual blades holding themselves together or their design. So that's why my blades work fine. I have them in there. They've been working great. And just as they were designed to. Put plastic in, they still work great. Turn the speed down, and they work great. Turn the speed up, and they work great, because they're putting all their pressure in the actual machine, not on the shaft. They spread it out along the whole point of the machine. So it's actually technically the strongest form of an auger, because it's spread out amongst the whole machine. The weight is evenly distributed. The only issue is, if you do it how I did it, I currently don't have a liner in there, so there's very high friction. But that's not necessarily the case, because there is going to be a layer of oil in there. There already is a layer of oil. Now we've been running plastic in there. Layer of oil, carbon, plastic, and grit. So it's not metal to metal, but it is higher friction than if you had a liner in there to reduce the friction, right? But those shaftless auger blades are very intentional as well. So let's say I even did find out a way how to make it work with the shaft, right? It just wouldn't be as efficient as the shaftless auger for a few different reasons too. So that's the goal of that. Let's see, we have any more questions here? You said you could also turn the whole machine. I've looked into that, like the cement mixers, turn the whole barrel. I've looked into that in my early stages, and I immediately just left that idea when you think about trying to mount microwaves to a spinning barrel with wires. It's just like, that's a headache I don't even want to deal with. Is there a reason you didn't isolate your machine? What do you mean by isolate my machine, Sam? What do you mean by that? Are you talking like electrical isolation? What type of isolation are you talking about? Heat isolate. Oh, you mean insulate? Well, I didn't insulate it because it's still being built. Once the machine is built, it's going to be insulated. Because we don't want to lose heat. We want to keep as much as we can, right? So I'm going to insulate it once everything's added to it. In fact, the only thing at this point that needs to be physically like welded onto the machine are the rest of the microwave mounts. After that, everything else is just bolted on and stuff. So we're actually almost done with all the welding of the machine itself. And then we have to make the oil collection tank and the carbon collection tank. Other than that, the machine itself is done. But then we have to build the electronics cabinet, right? Which is going to come over time, and that thing's going to take a while. Heat is going to get out of the chamber, yeah. Not as much, though, because it's microwaves. So since we use microwaves, You know, by the time the body is like 100 degrees Fahrenheit, the inside is like 300 degrees, right? Because microwaves heat from the inside out. So, you know, you said, is your reactor funded? My reactor's 100% funded off of your donations, everybody. So, you know, when you see Mark 4.5, you see it running, you see how well it's coming along, just know that you guys are just as much of a part of it as I am, right? It's literally 100% crowdfunded. So I appreciate every single one of you who support, donate to the Cash App, everything, because that's literally how we make this reactor possible. You know, that's literally how we do it. So why are we not making gas right now in this moment? Well, the reactor currently, we ran it earlier today for 3 hours on live, and I like to do Q&As as well to engage with people more and answer the questions. So, you know, I run the reactor certain times of the day, and then I Q&A some certain times of the day, right? What's your plan to scale this up? Well, the real plan is just to continue to build it like I've been building it and see what we get there. So any investors yet? Not ones that I want, right? Not the type that I'm looking for. What state do you need a permit? You definitely would need a permit if you're trying to do this industrial or properly, right? I'm in Georgia. Thank you, Jay, on the TikTok. Have you actually turned plastic into fuel yet? Yeah, so we have turned a little amount with Mark 4.5. In fact, I think we literally collectively got 2 drops of fuel out of it in our little test runs, right? We made some natural gas as well. The main thing is we have to get it to a point where we have more power going into it before we actually get real fuel, because the machine is just not getting hot enough, and the machine is too big. It's so much volume that the heat that we're getting is just not sufficient for making fuels. But we're still trying to figure this out. I've been thinking about the microwave transformer. Could you use 2 secondary coils to 1 primary coil? Look, like I said earlier, I'm not an electronics person. I can't advise you down that route. I just do the basic circuitry. I do what works. I wire up the transformers. I do what I need to do, and that's it. I don't know any extra things with the electronics, right? You know, I'm slowly developing and understanding myself. I still don't. I mean, I know what the primary winding and secondary winding are, but I really don't truly have an understanding of how they work. I have an understanding of pyrolysis, and that's about it, man. What's up, Jesus? Did you do the welding yourself, Nick Smith, asked on Facebook? Yeah, I have. It was 035 flux core. Have you done any training in chemical engineering? No, I'm self-taught in chemical engineering. So you're my inspiration. Thank you, Mon 420. I appreciate you, and you know that's what we try to do above all else. Some systems preheat the plastics, yes. Probably primarily to remove all water from them, right? So what is your fuel consumption to production in your working model? I don't know yet, because we haven't run it at full power, and we're still looking to get to that point. But of course, when we get the machine functioning full power, then yeah, that's definitely one of the first things we want to do. Water can be good. That's true. Water on the plastics can help the process. But I don't, with microwaves, since they heat so quickly and efficiently, there's probably very little benefit to preheating the plastics, right? And God bless you too, Ethan Bahrain. But it was good talking to everybody. I know it was a little short of a live stream, but tomorrow, what we'll be doing is running the machine again with the blades on, and we're gonna get some big progress on the machine. Hopefully, we'll have 3 magnetrons mounted soon. So I'll see you all tomorrow when I go live. It'll be another long live stream again. Then you guys take care. I'll see you then.